So we'll start with the chapter 3 lexical analysis, the second part. In the first part, we have already seen the lexical analyzer, their functionalities, what exactly the lexical analyzer does. The remaining part of the lexical, it directly tells you, it's going to tell you what exactly the remaining functionalities of a lexical analyzer, its structures and all such things. So we'll start with this, the second part of your lexical analyzer. Okay, the lexical analyzer generator, that is the Lex. Now in these cases, what exactly we are going to do is we are actually using a tool that is called as the Lex or Flex to convert the language that is written in our Lex program, okay, and to have the tokens. Now the same thing is written over here, a tool called as Lex or Flex that allows one to specify a lexical analyzer by specifying regular expressions to describe the patterns for tokens. Now we already know that a lexical analyzer, given a input, it generates and gives you the tokens. The input notations of the Lex tool is referred to as the Lex language, and the tool itself is a Lex compiler. The Lex compiler transforms the input patterns into a transitions diagrams and generates a code in a file called lex.yy.c that simulates its transition diagram. Now whatever is written over here, I'll explain you all with a diagram. So what exactly we are going to do is, we will be having a Lex program that will be written in the Lex language, that is the file name .l. So here the file name is lex.l. So that program we are going to give it to the Lex compiler, where we having a file that is, it is going to generate, the Lex compiler will generate lex.yy.c file. This lex.yy.c file, we are in turn supposed to give it to the C compiler, where we are going to have the output as a.out file. Now inside the C compiler itself, along with this a.out and the input stream, we are going to generate the sequence of tokens. So students, just keep it in mind, whenever we are having a program that is written in a Lex, okay, you require two compilers, that is the Lex compiler and the C compiler, to have a sequence of your tokens. The next is your structure of your Lex programs. But before going to the structure of your Lex programs, the things that you are going to supposed to keep in mind, you have already seen that some attributes, values and alls are being generated. Those attribute values, no matter for example the pointer to a symbol table, all such things are actually being kept in a local global variables. So everything, your attribute patterns and all, I'll explain you all what are attribute patterns are. Now can you all see this attribute patterns, that is less than, equals to, not equals to, greater than or greater than equals to. Those attributes values are this. All these things are actually being stored inside a global variable called YYLVAN. Okay. The next thing we are going to study is the structure of your Lex program. The structure of a Lex is actually divided into three parts. That is the declarations part, the translations rules and the auxiliary functions. So inside the declarations part, no matter how many variables you are using, all the manifest constants and the regular definitions are actually being declared inside the declarations part. That is, they are going to put it inside the declarations part. The next part is your translation rules. The translation rules is actually divided into two parts, that is the patterns and the actions. Patterns are nothing but a regular expressions. Whatever the regular expressions are will be there inside the patterns, and in case suppose the matches to the patterns are there. Okay, I'll explain you with an example in the further slides. In case some things, okay, that is the lexeme matches to your patterns, or the characters that has been given matches to the patterns, then what actions you are supposed to do, okay, that will be there inside the actions part. The next one will be the auxiliary functions. So inside the auxiliary functions, the additional functions whatever are there has to be stored inside the auxiliary functions part. Okay, before going to the next with an examples, the lexical analyzer created by the Lex behaves in consonant with the parser as follows. How exactly the lexical analyzer behave with the parser? The parser is nothing but the next phase of your compiler. When called by the parser, the lexical analyzer begins reading its remaining input one character at a time until it finds the longest prefix to the input that matches one to the patterns. Now over here what we are going to do is, we are going to give the patterns. Okay, those patterns we are supposed to actually match with one character that is there inside our programs. In case suppose it matches, then those only we are supposed to, what actions and all we are supposed to do, we'll see with an examples and all. Okay, for example, if white spaces and all are there, for example, new line or tab, all these things we cannot pass to the next phase, that is the parser. But yes, if the tokens are there, if the matchings are there, okay, then we are supposed to pass those to the next phase, that is the parser. It then execute the associated actions, okay, depending upon what the actions are to be taken once the patterns matches matched. Typically AI will return to the parser, but if it is not, that is, for example, because pi describes white space and the comment, if white spaces are there, then we are not supposed to pass it to the parser. Then the lexical analyzer proceeds to find the additional lexemes until one of the corresponding actions causes a return to the parser. The lexical analyzer returns a single value, the token name, to the parser, but uses a shared integer variable, that is YYLVAL, to pass the additional information about the lexeme found if needed. Now explain on what exactly is YYLVAL. Is nothing but it's a global variable. Now, this is the tokens that are being given their patterns and their attribute values. Now, if you go to see lexemes over here is the white spaces. If, again the token name will be your if, then, else, the else part. Then any ID that is going to go to the table entry. We already studied that we are supposed to store inside the symbol table. Numbers, again a pointer to the table entry. Then less than is nothing but a relational operator will be the token name, LT. Then less than equals to, again a relational operator, LE, equals to a relational operator, equals to, not equals to relational operator, it's a relational operator, and this will be your NE. Greater than, again a relational operator, greater than equals to, again a relational operator, and then greater than equals to. Now whatever this programs you can see, I'll explain the same structure over here of your Lex. Now it is divided into three parts. The first parts we have already seen is the declarations part. So inside the declarations parts, can you all see all the constant, that is the manifest constant which are there, are actually declared over here. That is the less than equals to, greater than equals to, if state, then if, then else. All these keywords and all ID numbers are actually being put inside the declarations part. Along with this, you also will be having the regular definitions which have been declared over here. Okay, now inside this, can you all see delim is nothing but the delimiters. So whenever you encounter a /t, tab, or a new line, which we are going to put inside the delim. Delim is nothing students but a delimiter. The delimiter is again put inside the WS variables. Can you all see over here plus sign? Plus sign indicates is nothing but your one or more than one letters, that is A to Z, in capital cases as well as in smaller cases. Digits, in case suppose you are having any numbers. IDs can be what, a letters. Okay, along with the letters you can have a digits also. For example, program 1 we write down as a variable name, so PROG1. In case suppose you can see over here, it can be either combinations of many letters or with the digits. Multiplication signs you can see over here. Okay, it indicates 0 or more occurrences. Numbers will be what, your digits. Slash and a dot. Okay, slash and a dot is actually indicates that it can be any characters. Now you'll be having your numbers with the floating points and all, so it will be what, your numbers with many numbers. Okay, so plus sign indicates what, more than one. Fine. Slash dot, so it can be a floating point number also, plus. Okay, the question marks indicates what, is nothing but 0 or 1 occurrences. E is for the exponential parts and all, plus or minus. Exponential part plus or minus, E also will be there. Okay, and the digits. Okay, question marks you all know is nothing but 0 or 1 occurrences. So this will be there inside your declarations part. As far as the translations rules are concerned, you will be consists of the patterns and the actions. So in case suppose it encounters, you will encounter WS nothing but the delimiters. You are not supposed to take any actions. Suppose you encounter if we know, then, else are nothing but the keywords. So you are going to return as if, that is if, then, and the else part. Suppose you encounter ID, so that you are going to store inside the global variables, that is YYLVAL. Okay, so id in turns you are going to call the function, that is the install id. Number, again you are going to store everything inside the global variables, that is YYVAL. Okay, int install now. Now the moment if else your if then else is encountered, so you are going to return it and store. But the moment you encounter id and number, id or number, it is actually having the functions, that is you are calling the functions install id and the install num. So in these cases, what are the three things you are supposed to keep in your mind regarding the functions part? The first thing is function install id is called to place the lexeme found in the symbol tables. Next, the functions returns to a pointer to the symbol table which is placed in a global variable, that is yyLVAL, where it can be used by the parser or the later components of the compiler. Note that install id has available to these two variables that are set automatically by the lexical analyzer that Lex generates. Now in these cases you are going to have, that is YY text. YY text is nothing but a pointer to the beginning of the lexeme. So it is will be a pointer analogous to the lexeme begin. In this lexeme begin we have already studied inside your part 1. So whenever you are actually having a buffer, okay, and you are supposed to read a character, it will start with a pointer, that is the lexeme begin. Next, YY is actually used to find the length of the lexeme. The third one says that the token name ID is returned to the parser. So this you are going to store, this you are going to store and then they return to the parser. The same thing, whatever you have done for the functions install ID, the same thing will be there for the install num functions also. So that is the actions taken when the lexeme matching the pattern number is similar using the auxiliary function, that is your install num. So whatever it is there over here, it will be the same thing for the numbers. The same thing then, if you go to see, if there are other operators, that is less than, equals to, not equals to, greater than, equals to, actually being stored inside the your global variable, that is YYLVAL. So you are going to store, that is LT, LE, EQ, NE, GE, and you are going to return the relational operators. Okay. The next part says that conflict resolution in Lex. We have alluded that to the two rules the Lex uses to decide on a proper lexeme to select when several prefixes of the input matches one or more patterns. So in case suppose there are more patterns are being matched, first one what you are going to do is always prefer a longer prefix to the shorter one. If two are matchings are there, okay, two prefixes are matching, then obviously you are supposed to go with the longer ones. If the longest possible prefix matches two or more patterns, prefer the patterns listed first in the lexeme program. Now the next thing what we are going to do is the look ahead operator. Now why exactly we require a look ahead operator? Now we already know that in the programming like your C, C++ or Java, some of the keys are actually reserved. Okay, for example, your if, else, part, then, these are nothing but the reserved keywords and you actually cannot use them in as a variable name. But in earlier programs, for example in Fortran and all, those reserved keywords can also be used as a variable name. So how to actually tell, okay, the compiler, okay, this particular word is actually be used as a keyword, okay, and so on. So in such cases, we require the look ahead operator. Lex automatically reads one character ahead of the last character that forms the selected lexemes and retracts the input. So only the lexeme itself is consumed from the input. However, sometimes we want a certain patterns to be matched to the input only when it is followed by certain other characters. If so, we use the slash in the pattern to indicate the end of the part of the patterns that matches the lexemes. So we are going to use the black slashes. What follows the black slash is additional patterns that must be matched before we decide that the token is a question was seen. But what matches the second part pattern is not the part of the lexeme. I'll explain on what exactly is written over there in the previous slide. Now, for example, in Fortran, some other languages keywords are not reserved. That situation creates a problem, such as a statement. Now, we know that if is a keyword, I, j is equals to 3, where if is a name of an array over here and not a keyword. Okay, just keep this in mind. This statement contrasts with the statement of the form. Now here if is nothing but a key array, but if you go to say over here, if is nothing but a keyword, that is if conditions then. If the condition is satisfied, then what exactly you are supposed to do? Where if over here is a keyword. Now in such cases, how exactly to differentiate between if that is used as a variable name, that is over here as an array, and over here if when it is used as for the condition purpose. Fortunately, we can be sure that the keyword if is always be followed by a parenthesis. So in this cases we know that if is always going to get followed by a parenthesis. Okay, some text the conditions may be contains parenthesis, the right parenthesis and a letter. Now in these cases we know that we are going to have this parenthesis followed by some conditions and one closing one. So in such cases what exactly we are going to do is if the slashes, the black slash, again a bracket with a dot and a asterisk. The dot and the asterisk indicates that it can be having a n numbers of the conditions. The conditions can be anything, followed again by a black slash and the closing brackets, and then again followed by any numbers of your letters. So in these cases it directly indicates that if is nothing but a keyword. Students, with this we are done with the remaining part of this chapter. I want you all to go through this chapter properly. There are some things like we have already done in ATC. So the regular expression, the DFAs, the NFAs. So kindly go through that, and in case suppose you are having any difficulties, please do let me know. I'll clear down your doubts. Okay, and go through this slide as well. Thank you.